Now, for our next presentation, which is not editing the title of the presentation, it's opening the presentation. Okie dokie. I would like to welcome Trevor Greissinger. Did I say that properly? Trevor, he's talking about the NHL-Drafted skater development in NCAA hockey. Trevor graduated from the University of Michigan in 2019 with a degree in statistics. During his time there, he worked for the Michigan Wolverines men's hockey team as a data and video analyst, collecting statistics during and after games and writing software to analyze the data at a player level. These results were used to build dashboards that coaches could quickly review to get a snapshot of a player's performance. Trevor's hockey research interests include prospect analysis, especially for NCAA hockey, zone entries, and power play strategy. Welcome, Trevor.
Thanks. Hey, everyone. So to give a little background, it sounds like Nyan and I are pretty similar in our interests. Me at a school a few hours north. But so this research question came about when I was doing work for the Michigan hockey team last year, and I was having a conversation with another person who worked for the team about how we could entice players to stay at the University of Michigan for longer. Obviously, in NCAA hockey, you have a finite amount of time with the players before their eligibility is up, but a bigger problem is elite players leaving early to sign their entry-level contracts. So I wanted to do some research to see if we could quantify exactly why or whether or not there was an impact on players staying additional years in college hockey with how they would do in the professional leagues. So my initial hypothesis was that we would find a positive correlation between increased years staying in college hockey with professional success. So collecting a lot of data on NCAA hockey, as Nyan mentioned, is a problem because of how limited it is, especially at the player level. On the team level, you have some measure of shot differential and Corsi. On the player level, it's really hard to find that. So my model is sticking mostly with positional effects, the years they played college hockey, and points per game. And so scraping all of this data from elite prospects, I found between 2007 and 2017, about 300 players who had a full season of college hockey experience, and then in the next season went on to play at least 20 professional games. And so that's the scope of this project. Professional success is a difficult thing to measure. Obviously, WAR is a very nuanced statistic and still in its nascent stages in hockey. However, I chose to use games played rather than any counting-based metrics for the reason that if we're trying to entice a player to stay longer in college, what they're giving up in earnings potential as what they could be having on their first couple years of their entry-level contract could be made up for down the line. So I wanted to, this is working under the assumption that additional years in college hockey will lead to greater expected value of their contracts over time. And I chose professional games played because this is a model that assumes that a player who plays more professional games in their first couple of years is likely to have a higher longevity of their professional career. So I'm using a non-parametric bootstrap here to estimate the professional games played. And we're going to be using this to build confidence intervals around the regression results. And that's going to be able to give us sort of an answer to this hypothesis test about whether or not additional years in college hockey does have any impact on professional success. It's appropriate here because the bootstrap does really well with small sample sizes, about 300 players here, and we know that they're representative of the population of interest because they are exactly the population for that time period. And we can verify that there is a linear response between the response and predictor variables here. So the counting statistics we had available were very small, so I used all of these. I fed all of these into the model and then used a procedure called exhaustive search to select the most predictive, and found that maybe intuitively, number of NCAA seasons, NCAA points per game, and player position were the most predictive features in this model. So here are the results on our eventual data. I included the confidence intervals, but mainly at the estimate column, you can see To interpret this, the intercept is essentially what our base estimate is. And so you can see position forward. This means that we would expect a forward to play approximately 6.5 fewer professional games per season than a defenseman. And so there's also a very high coefficient for points per game, which makes sense because players who produce highly at the college level are expected to produce highly at the professional level as well. And the interesting thing here is that with increasing seasons, as you can see, these NCAA seasons 2, 3, and 4 show a negative coefficient, although the 95% confidence intervals around these regression coefficients all contain 0, which means that at a 95% confidence level, we can't conclude that staying for additional years has any impact on their professional games played. I broke this down a little bit further into the positional effect, so we can see that because the distribution of points per game is very different between forwards and defensemen, I broke the model down a little further and found that this positional effect does incorporate a little bit into professional games played per season. So defensemen are expected to play more than at the higher level than forwards, but the error bars on these are pretty wide, so it's hard to make a strong conclusion on that. So my initial hypothesis was not met, but I think it's important to note that because those confidence intervals all contain 0, we know that there's no, at least at that confidence level, there's no way of determining whether or not additional years do increase professional success, at least how I've defined it here. And as Nine got into a little bit, the biggest problem here is lack of data available in NCAA hockey. And as Hannah mentioned as well, time on ice would really be nice to have, so we could look at rate-based statistics as well. And so that, I'll give the rest of my time back to Allison, and thank you everyone for attending.